First off, good day to everyone, and thank you for joining us for the first of our, our second of our webinars we're doing for this week for the RTS 2020 Spring Showcase. We hope that next year we can actually see all of you in person in Las Vegas, but for this year, we're all going to be socially distanced and safe. We have 4 presenters today. I am Doug Heinzen. I'm the North America Marketing Manager for RTS Intercoms and Telex Radio Dispatch. I will also be the moderator for this presentation today, and I'll be watching for comments in the comments section to see if there are any concerns. We do know that from yesterday's presentation that we were having some people getting kicked out of the session and getting readmitted, so if that happens, I'll do my best to readmit you as quickly as possible. The other presenters we have today, there will be Ethan Wetzel. He is our platform strategist, and he'll be discussing standards today. Greg Compagnon, our North America Sales Director for RTS and Telex Radio Dispatch, will go over some of the history of the company and what RTS is. And then we'll end up with Amaury Ramos, and he is our Global Training and Knowledge Manager. And for today, we will be recording this session. Questions will be answered at the end of the portion of the presentation that Ethan does on standards, and we'll also check for questions again at the very end of the presentation, just to make sure we haven't missed anyone. If you need to ask a question, please just click on the chat button to show that you're in there and write your question in, and we will take care of that at the correct time during the presentation. Now, at this point, I would like to introduce Ethan Wetzel and get him up and talking to you about standards. Thank you.
Thank you, everybody. From my side, I'm really appreciative that everybody was able to take some time out of their day to join us for this webinar. I do hope that everybody is staying safe and healthy and as comfortable as you can, and we'll do our best in the next hour or so to try to take what can be a somewhat dry topic and make this informative and entertaining for all of you. So a little bit of background on myself. I've been with Bosch for about 20 years. I've been working in the audio industry for about 30 years, doing a number of different things as a system designer, technician, user, product manager. And these days, I work in the platform engineering group for Bosch Communication Systems. This is a section of our company that is devoted to creating long-term strategic and core technology that actually gets used across all of the business lines under Bosch Communication Systems. And a big part of that role is also spending time working with the standards bodies and trade associations that help develop some of these new media networking technologies and other standards for our industry. And this is really what we're going to dive into a bit today to provide a little bit of insight and illumination and background on how some of all this great stuff comes to be. So one thing that I think is really important to start out with is RTS has long been a very innovative and technology-focused company. As it comes to technologies for connecting systems and connecting devices, RTS really has an incredibly deep roster of different technologies that can be deployed. Everything ranging from IP standards to compression codecs, of course, implementation of Dante, 4-wire and 2-wire analog technology, and of course also Arvon. So regardless of the size, scale, or complexity of your system, I think it's important to understand that RTS really has a technology and a solution that's able to fit anything that you may come across in the field. Now, today, what we're going to dig into a bit more is some of the emerging standards and some of the things that are really coming into the world of media networking that are being encountered in the field by broadcast and other applications that are really sort of pushing the forefront of some of the technology. So we'll talk a bit about specifically AES 67, AES 70, and SMPTE 2110, and how all of this winds up relating to each other, and certainly the products and the applications that we come across today. So let's really start at the beginning. The world of media networking and standards in general can become very, very confusing very, very quickly, just because there are so many bits and pieces and 3- and 4-letter acronyms and terms of art that get tossed around. That's very, very easy to become muddled and confused as to how some of these things relate to each other and what is really important to be paying attention to. So let's just start with some foundational background on what exactly we're talking about when we dig into some of this technology. Fundamentally, in a media network, we're talking about 3 primary building blocks. So we've got our protocols, we've got our standards, and we've got our solutions. And these are building blocks that are developed and promoted and supported and implemented by a number of different players within the industry. You, of course, have the standards bodies that create the technology and the references themselves. You have the trade associations that deal with education and promotion. You have the manufacturers, of course, that implement the technology. And last and arguably most importantly, there is you, the users, who have to actually interface with this stuff and turn it into working systems at the end of the day. And just to show what a strong supporter of industry standards we are, it's become a de facto standard within the industry that anytime anybody does a presentation related to standards, they are required to show this XKCD cartoon. So I'm doing my part and actually flying the flag so we can poke a little fun at ourselves. All right, so what exactly goes into a media network? It's both deceptively simple and complex at the same time. Fundamentally, a media networking solution requires 4 components to be able to achieve what it's trying to do. The first primary component is transport, and this is where we're going to take our content, whether it's audio or video or other type of data related to the program that we're trying to move around the network and get from point A to point B. The program transport is going to be responsible for taking that digital content, putting it into Ethernet packets, formatting it correctly, going through the network and actually routing it from point A to point B. So this is really our transport for getting the program around inside of the network. But this really needs to be complemented by a number of other things in order to really form a complete solution. So the second primary component that we need to have in a media network is an element of system control. This is going to be the component of a media network that is responsible for not only adjusting the parameters of the devices, turning things on, turning things off, changing cross points, getting VU meters, that type of thing, but it also handles some of the fundamental housekeeping work inside of a media network, setting up connections, closing connections, monitoring status, all of those types of functions that require device interaction fall under the system control component. Now, both the transport and the system control component need to be supplemented by 2 additional elements that are really fundamental to the media networking solution. The first is time services, and this is the mechanism that is going to be responsible for maintaining timing and synchronization across all of the devices within the network. This is where we're going to manage things like latency and packet synchronization. And that is something that actually affects both the transport as well as the control, because we need to make sure that everything stays in full synchronization. And last but not least, we have what's referred to as a directory service. The directory service is just what it sounds like. It's going to maintain a list of all of the devices that come onto the network as they come, as they go, and keep track of who exactly is participating in the network at a given time. But it goes a lot further than just maintaining a list of devices and addresses. It also needs to deal with enumeration of what those devices are. What are their capabilities? What am I able to do with that device? And human readable names, things that we as operators need to actually be able to grab and touch and see to be able to get the system to operate as a complete solution. So as we go through the presentation, kind of bear these four components in mind: the program transport element, the system control element, the time services element, and the directory element. Those are the four fundamental pieces that we need to have for a complete media networking solution. So let's take a little bit of a deeper dive into some of the specific building blocks. Some of this may come across as a little bit pedantic, and the use of the correct term doesn't matter until it matters. So I'd like to talk a little bit about what the specific meanings of some of these components are. Now, a protocol is a specific set of communication rules that was created to do a specific job. And some examples of these are IEEE 1588, which is a time services protocol, TLS, Transport Layer Security, which is an encryption protocol, HTTP, et cetera, et cetera. These are protocols that are designed and purpose-built to do a specific job and are created by a number of different groups and offered up to be included inside of different pieces of technology. Now, a standard is a little bit different because this is going to be an agreed upon way of doing things. And some standards can implement multiple protocols. So a protocol can be a standard, and a standard can contain multiple protocols. A good example of this is something like AES 67 2015, which incorporates a number of different protocols, but enumerates a very specific way of implementing them. Lastly, we have what we refer to as a solution. Now, a solution is a complete technology stack that's going to implement multiple protocols and multiple standards, and may also include some proprietary elements as well. Now, examples of these could be seen in things like Dante or Ravenna or Bosch's own Omnio. These are architectural solutions that include a number of pieces of technology that come together to form a complete package. Many of those components are open public standards, but in some cases they also include proprietary elements that have been added to add more functionality or more value when needed for the given solution. So an example of how some of this can be visualized is if we take a look at some of the elements that go into AES 67, we could see that this is a standard that has been built up using a number of different protocols. And the standard itself defines not only what to use, but also how to use them. So the punchline here is standards can include multiple protocols. Not all protocols are standards, and solutions can contain both standard and non-standard protocols. So this is just a little bit of an entry into the wonderful world of technology. Let's take a little bit of a deeper look into some of the ways that these different structures and building blocks can come together. So it's important to understand that a solution is going to be a hierarchical structure. We're going to take these fundamental building blocks and combine them in ways to add value and add functionality to a given solution. So these components will build upon each other and complement each other and be nested within each other to create something that provides more functionality. And it's important to understand that different kinds of interoperability can be found at different levels of nesting. So at a very fundamental level, I could have two systems that are able to exchange clocking information, for example, but are not able to exchange control information or any other type of service that would be functionally valuable to a system itself. But as we begin to add more functionality to that, such as audio or maybe discovery components, we're adding more functionality, but we're also creating more dependencies from one implementation to the next, because of course, the more functions you have, that needs to be supported on both sides of the equation. Generally speaking, the higher up you go in these stacks, so to speak, the more feature-rich your interoperability is going to be. So if I connect, for example, two Dante devices to each other, they have a very rich repertoire of not only internal media networking functionality, their clocks can be exchanged, able to use the same configuration elements. All of those things are bespoke pieces of the solution, and I get more functionality if I stay within the same family. So this is a very important concept when we begin to look at how some of these standards and protocols actually interoperate with each other. And one common question that I get when I talk to people about this is if they should use AES-67 or if they should use Dante. And because AES-67 can be a component within Dante, the answer, of course, is yes. So how exactly does this look? Well, let's start out with a media network. And the first thing I'm going to need to do is be able to move my content back and forth. So I'm going to choose a protocol to do that. And in this case, I'll choose RTP to make that possible. Then I want to add a time service because I need to maintain synchronization across all of my devices. So I'll add IEEE 1588. Now, I want to go further. I want to add some more stuff. So I'll add some tools for managing my audio. I will add discovery services so I can discover and enumerate my devices and my capabilities, find out who's on the network, what are they capable of, and what are some human readable role names that I can use to interact with those devices. But let's keep going. Let's add some tools for system management. Maybe I want to be able to track things like system functionality or health, or look at other components of my system as a complete entity. I can add additional things such as parameter control. I could add redundancy. I could add encryption and security. I can keep adding these additional functions and these additional benefits into my solution to get a more and more feature-rich solution on the market. So now that we've sort of determined how exactly we want to begin to add some of these building blocks, now we can begin to draw some boxes around them to see how they relate to each other. So fundamentally, if I'm just exchanging clock and audio and a few other fundamental things to move my audio information back and forth between devices, I can call that AES-67. If I then go and I add additional services and additional protocols on top of that, now I can begin to call that Dante. And we could see here how AES-67 becomes a component within Dante itself. So those two things are complementary as they nest within each other. And lastly, we can go all the way up the stack to look at something like Omnio that goes beyond what these solutions and standards provide and actually incorporate additional robust control sets, encryption, redundancy, and a number of other things. So this is how these different pieces relate to each other and how exactly they interact and complement and support as we go up from the fundamental building blocks to a complete solution stack. So let's take a little bit of a deeper dive into some of the specific technologies themselves. AES-67 has been around for a few years, and this was really born out of the early genesis of audio over IP. There were a lot of options and solutions that were coming onto the market. We had Dante emerging, and of course there was Ravenna, there was Livewire, QLAN, a number of other solutions, all of which were taking audio, putting it onto a network, and getting it from point A to point B. But the problem quickly emerged that even though there were all of these great solutions that were fundamentally trying to do basically the same thing, none of them could actually speak to each other. So we, as designers and integrators and users, had to resort to some fairly dirty hacks to try to get around that. We would have to implement converters, turn everything over to an AES-10 stream to link one island to another, or worst case scenario, convert everything back to analog, bridge this device to that device, and then we can go digital again. Really sort of shooting ourselves in the foot and getting rid of the entire benefit of going onto the network in the first place. So a number of concerned parties got together and said, this isn't so great. Let's see what we can do to actually try to solve this problem. So the survey began, and what we did is we began to look across the industry at all of the different audio over IP solutions that were existing on the market. And this image here is just showing 4 of many solutions that were available at the time. And what you can see here is fundamentally all of these solutions, again, are doing more or less the same thing. They're using protocols and using different pieces of technology to deal with things like transport encoding, session description, managing connections, dealing with clocking and time services. But the problem is all of them were dealing with it in slightly different ways. And because of that variation, none of these systems could talk to each other. They were about 90% the same, but enough variance was in the way they were implemented that nothing could actually speak to itself. So after examining all of this and digging into where there were these differences, we began to look at what a good solution would be for harmonizing the way that this media network transport was handled, while at the same time leaving enough room for the additional features that made Dante or Ravenna or QLAN unique and special. And ultimately what this turned into was what was called AES 67 2015. This was the first release of the standard itself. And what this really did was create a standard repertoire of protocols that would be used to handle things like media clocking, synchronization, transport, and a number of other functionalities that are needed inside of a media networking transport solution. So what this basically did was create a component that could be added into Dante and Ravenna and the rest of these solutions to handle just the audio transport and the synchronization methods between them to allow this base communication and interoperability between the different islands to allow them to exchange audio and clock between each other without having to go through extra conversion. Now, one thing that's very important to understand about AES 67 is it intentionally drew a very narrow window of the problem it was specifically trying to solve. And this is related to the audio transport and the clocking. It was not intended to deal with things like control or discovery or a number of other things that had already been implemented inside of the existing solutions. It intentionally drew those lines to be able to be adoptable, acceptable, and functional within existing technology. So AES 67 was never really intended to be a complete solution. It was intended to be used with and complemented by additional pieces of technology to create something that was much more complete. And this is very important to understand because when we're doing evaluation of different technical solutions that are on the market, such as Dante or Ravenna, AES 67 complements those solutions. It doesn't compete with them because it becomes another one of those building blocks that goes into the stack itself. So we've talked about transport and we've talked about time services, but once we are able to get our content onto the network and move it around, what are we going to do once it actually gets there? We need to be able to interact with our devices. We need to be able to control them. We need to see what their statuses are and be able to talk to the devices as if they were in front of us. And this is where system control becomes really, really important. And this is where OCA or AES 70 comes into play. Now, some of you may have heard the term OCA, some of you may have heard AES 70. OCA stands for Open Control Architecture. And back at the time that we began to work on this technology in 2011, it was before it had been standardized. So we chose the name Open Control Architecture to describe the specification, the object tree, and everything else that went into it that we were actually developing it. Once that specification was done, we handed that over to the AES, and they took it through the standardization process just as they would any other technology. So AES 70 became the standardized name of OCA. And this is very similar to MADI, which is also known as AES-10. Now, AES-70 and OCA were originally developed by the OCA Alliance. This was a nonprofit trade association that was started with 11 members from around the industry and was developed over a period of about 3 years before being handed over to the AES, where it went through the normal standardization process and was then released to the public. Now, OCA itself and AES-70 live alongside any other program transport to be able to offer that other fundamental component of a media network. It's capable of living alongside any or no media transport and just act as a control standard on its own. Fundamentally, AES-70 contains an object-oriented framework that describes all of the control elements, parameters, and objects within a device. So things like gain controls, matrices, cross points, VU meters. Those are all functional components that exist within a device that are able to be expressed in an object-oriented way using AES-70. It also contains a device object model that actually describes how to enumerate and how to lay out these components themselves so they can be expressed as an object-oriented device. One of the things that's really important about the way AES-70 was architected is it was developed as a highly extensible and very flexible set of control classes. So if I'm going into a device, I have standard object classes that will describe something like an EQ filter, a gain setting. But it's also possible to create additional classes and extend that and then advertise those objects to other controllers or other devices that may not have known about them previously. So it's simultaneously very, very flexible to be able to customize for a specific device or a specific application, but to do that in a way that still remains standard compliant and accessible from other devices and other systems that may not know about it. It also, of course, includes the application protocol for bundling up that information and sending it across the wire. But what it does not include is any sort of program transport. It can live alongside of AES-67, Dante, Ravenna, anything else that you could throw at it. It's very agnostic when it comes to the types of transports. It doesn't indicate any way that the devices have to be programmed or how the user interface has to be developed. It doesn't contain definitions for things like algorithms, and it doesn't contain profiles. So it's very, very flexible to be able to implement inside of a device, but it doesn't overstep its bounds. It does exactly what it's intended to do and no more. Here's an example of how some of these objects look within an AES-70 device. So we could see here that the functional objects within a piece of hardware exist as these object-oriented blocks. Those are described and enumerated externally to controllers or to other devices in an object-oriented way. And this becomes a very easy, very human readable, but very, very flexible method for actually describing everything that's going on inside of a device. So I think this is probably the watchword for this industry of the past couple of years, ST2110. What is it and how exactly did it come to be? Well, as many of you know, there has been a lot of different approaches to building up and moving around content and control inside of a broadcast facility. And some of those had challenges when we were dealing with single stream encapsulation of all of the different types of data that I may need to send around in a facility. Bundling up my audio and my metadata and my clocking and my video and everything into a single stream onto a single wire created a lot of challenges. It made it difficult to migrate. It also created some inflexibility and some complexity when you needed to interact with just one of those components. For example, if I just want to pluck off my audio, do some post-processing to it, and then re-inject it, that was a complicated process. So as the broadcast facility began to make the transition over to IP, the standards bodies and the groups that work on this stuff looked at it and said, you know, there's probably a better way to do this. And one of the approaches was to create what's referred to as a essence-based architecture. What that means is each of the data types essentially becomes its own dedicated stream. So video becomes its own stream, its own essence. Metadata becomes its own essence. Audio, clock, all of those become their own essences that exist independently on the IP network. But in order to make this possible and not reinvent the wheel, what needed to happen was a long process of surveying the technical landscape to see what other types of standards and technologies were available that may be suitable for each of these roles. So when the ST2110 suite of standards was developed, from the get-go, it was determined that it was not one thing. It was going to be a collection of different standards and technologies that were able to address this converged essence-based IP media network that was going to be required for broadcast facilities going forward. And as the survey of these technologies was being done, different pieces of tech were pulled in from different parts of the industry. So the Audio Engineering Society, the IEEE, the IETF, and several others all contributed technology into what would become the ST2110 standard suite. Now, in addition to these standards, there are additional pieces of technology that can be used to work alongside or complement or support ST2110 implementations. And an example of this is NMOS from the Advanced Media Workflow Association, or the AMWA. NMOS itself is broken up into multiple different elements. So we have ISO 4, ISO 5, ISO 6, and several others that are in place today and are being developed on the roadmap. But you can see how this very quickly becomes a changing and a complex landscape of lots of different technical components that go into making an ST2110 solution. Just to sort of highlight that, this is an image, a simplified image of some of the protocols and standards that have gone into forming ST2110. And we could see here how different pieces of technology, such as RFC 768, which then merged into IEEE 1588-2008, sort of work their way through the filter and the meat grinder to get into the solution stack. Things like AES 67 were also pulled in. Technology from the VSF were pulled in. So it really was a survey and a conglomeration of the best in breed technologies to try to solve this very complex puzzle of a converged IP solution for essence-based media inside of a broadcast facility. Just to pick on some of the specific components that go into ST2110 and how exactly these relate to each other. This is an image from the AINS Alliance roadmap that was dated October 2019. It's the most current one that is available today. This describes the different pieces of technology that are being combined with each other to actually begin to make the ST2110 suite and associated technologies that will work alongside of it. And a couple that I'd like to call your attention to become important when you begin to look at technology that may fit into your future ST2110 needs. Because it's a suite of different standards and different technologies, there are, of course, some standards that are not going to be relevant to certain pieces of technology or certain pieces of hardware. So, for example, 2110-20 deals with uncompressed video. In the case of RTS, when we're making a key panel that doesn't have a video component, we have no need to implement anything related to uncompressed video. So we're looking at the ones that are most important to us, which would be 2110-10, which handles definitions for timing, and 2110-30, which is a specific implementation of AES 67. To dig into that a little bit deeper, I think it's also important to understand the relationship of some of these technologies to 2110 and why exactly they're referred to as slightly different numbers. And I think AES 67 is a really good example of this. So ST 2110 had this need for audio transport, and AES 67 solved that problem. It was a great off-the-shelf standard that was able to do it, but there was a desire to add some additional constraints and some additional requirements how AES 67 was implemented to make it friendly to the solution inside of the specific application that the group had in mind. So ST 2110-30 actually imposed some additional constraints on top of AES 67 to ensure compatibility and best practices within its usage in a broadcast facility. Specifically, it's supporting a specific PTP profile. It requires a zero value offset between the media clock and the stream clock, and it requires a slave-only mode for PTP operation. For those of you that don't want to dig any further into this, just be aware that there are some differences there between vanilla AES 67 and 2110-30, with 2110-30 being a stricter interpretation of AES 67 with additional constraints. For those of you that do want to dig into some additional information and get really all of the details that we don't have time to go into here, the AIMS Alliance has created an excellent white paper that's available on their website that describes all of this in a bit more depth. So the last thing that I really want to touch on here is, as you can get a sense, not only is the technology complicated, but the industry itself and the players that go into defining all of these standards and these pieces of technology is complex as well. There's a number of different organizations and a number of different entities that are responsible for this. And one thing that I think is very significant to note about BOSCH is we are active participants in all of these groups. We actively lead, drive, define, promote, support, and implement all of these different standards. We take it very, very seriously that it's good for the industry, it's good for our users, and it's good for us as a company to really, really throw our full weight behind standards. So we spend a tremendous amount of time engaged in all of these technical discussions and really try to be industry leaders when we bring it forward. That spirit is really exemplified in our Omnio media networking architecture. You can see here, going back to my earlier slide, how we're building on different components and different building blocks, building on standards, adding these solutions to try to add more value while retaining interoperability and connectivity to other devices and the best in breed technical solutions that are available on the industry today. So we're very, very serious about supporting these open architectures and supporting these open standards. So with that, thank you for your time, and I yield back to Doug.
Hello, everyone, and I clearly understand that we've been having lots of dropouts on this session. I really apologize for that and whatever is happening with the network on that side. This entire presentation will be available on YouTube afterwards, and with that understanding now, I would like to get into some of the questions that were asked. The first one was, how, and this will be for you, Ethan, how does AVB MILAN fall into the standards and protocols?
AVB and Milan are certainly technologies that have been around for quite a while. There are fundamentally some very different technologies and approaches that exist within AVB and Milan. They handle the packetization and they handle the way the content works on a network much, much, much differently. I'll try to keep this brief, but AVB and Milan were always intended to really modify the network to make it as friendly as possible for media traffic, whereas other technical solutions really try to work within existing constraints on the network itself. And one of the ways you'll see that is with the AVB-enabled switches and dealing with things like stream reservation protocols to really lock down dedicated bandwidth. So it's another solution, it's another approach to the problem. There are certainly pros and cons to both sides. One thing that I would absolutely suggest is when you're evaluating one solution versus the other, take a very broad look at that and make sure that you're considering the size and the flexibility of your network, how converged it's going to be, what other type of IT equipment and hardware you need to add or might need to interface with, and if things like high scalability or routability across subnets are something that you need today. Having a better understanding of how these technologies relate to each other and where some of those trade-offs are made are very important. I will absolutely say that there is a place for all of these technologies. Certainly AVB and Milan have an application, and they do some things very, very well. Whether or not that's the right solution for your application is something that really needs to be determined on a case-by-case basis.
Thank you, Ethan. The next question coming in is AES 70 compatible with Dante as well as AOIP devices? They want to know about integration with AOIP devices in terms of audio.
I guess the best way to answer that is yes. AES 70 can coexist with absolutely any sort of transport or lack of transport that you may come across. So it could be put into any number of devices and peacefully coexist with any sort of audio transport or nothing. If you just had a dumb wall switch that didn't have any transport whatsoever, that could be an AES 70 device and happily talk to anything else. There are some provisions inside of the AES 70 standard that enable certain types of additional functionality, such as connection management and some other functions inside of a device or inside of a system. On the OCA Alliance website, that's ocaalliance.com, there are a number of presentations and white papers that actually describe how some of those additional functions can work. But yes, it's able to coexist peacefully with anything out there, including AVB and Milan, by the way.
Thank you. Another question. This is moving outside of RTS only, but staying inside of the Omnio realm. With other BOSCH products like the conferencing tools which run Omnio and could make use of 2110-20 video, will they go that route on those products or will they avoid it?
They would be able to, yes. I'm not going to comment on specific product plans or roadmaps at this time. I always defer that to the product owners. But as I say, we are always looking at open standards and where we can support those. One thing that is important to also consider is looking at things like compressed versus uncompressed video, latency, certain application requirements that may go into a specific application or a specific product. So as I say, we are very supportive of anything that involves open public standards. And if we can find an appropriate place to implement that, we're always looking to do that if we can. That said, we also don't go down the road of implementing things just for the sake of implementing them. So there does need to be a compelling application reason. But yes, we always look at implementing standards wherever we can.
Okay, the next question is, at a high level, what does 2110-30 implementation look like and how do we need to start planning for it now?
Boy, at a high level. I guess the way I would probably approach that is have conversations with your IT staff early to get a sense of what exactly is going to be needed to deal with implementations as far as switches and overall IT infrastructure. The good news is all of this stuff uses more or less off-the-shelf hardware, so there's nothing special that you really need to put into place to deal with this, but there are some things that you may want to consider implementing, like IGMP snooping for multicast filtering or other things. And it's a good idea to understand how that's going to work within the converged IT environment. Beyond that, what I would absolutely recommend is as you're beginning to do your research into this, bear in mind some of the things that we talked about in the presentation here. So, for example, ST2110-3 goes beyond AES67 and actually requires some additional features and functionality. So when you're looking at equipment that you may be plugging into that environment, make sure that you dig a little bit below the surface to find out what exactly has been implemented and have those conversations with the manufacturer and with their system design staff to make sure that you're really in the know as to how those things are going to work together. There's always a way to get from point A to point B, but you'd rather know about that in advance than when you're in the trenches with a couple of wires in your hands and having to go online in 5 minutes.
Okay, and the next question is probably going to be for Sean Anderson. Sean, it says that given many users still use RTS Adams intercoms, is there a way to get the use of the master controller that talks to the user via a web page?
Yeah, that is something we're actually looking at as we develop our next generation of control software, essentially the next iteration of what's known as AZ Edit and IP Edit. That is something that we're looking at currently. Still a ways out, still trying to evaluate pros and cons on that, but it is something that is currently being reviewed for our next generation of software. So yeah, I can have a further discussion on that at another date, but yes, it's something that we're currently looking into.
Thank you. The next question here says, okay, to some degree, AES67, Dante, Omnio, and ST2110 2110 audio can coexist on a network, and some streams can be compatible with several of those protocols at once. What software what software application would be used to make and monitor routes on that network? Would it be Dante Controller, a ST2110 routing program? How would that work?
I can field this one as well if you want, Ethan.
Oh, yeah, how about it?
Yeah, currently with our Omnio products are based on Dante, so they're fully Dante compatible. In the Dante realm, currently routing to things outside the RTS equipment portfolio, meaning third-party equipment, it does require the use of DDM to do the 2110 routing and to enroll devices within a domain that operates in 2110. Direct from RTS to RTS, those routes are set up through IP Edit. It handles the 2110 routing as well. It's just when you get into the third-party interconnectivity that you do require DDM to establish those multicasts for audio streams.
Okay, very good. And I believe at this point then we have completed through the questions, and I would like to now introduce Greg Compagnon. He's the North American Sales Director for RTS and Telex Radio Dispatch. And again, our apologies for the dropouts that we are getting on the network.
Awesome. Thanks, Doug. And thank you, Ethan. You really have a way of taking some daunting topics and making them very user-friendly. So we really appreciate your time today and joining the RTS session. So thank you to Ethan. The next two sections, just so everyone knows on the session today, the next two topics, we're going to go over the company profile, how RTS fits into the BOSCH family, and then we're introducing an RTS training platform that's new for 2020. So if you did sit through yesterday's session, these two will be a repeat of what we did yesterday, but you're more than welcome to stay on the line and join us here. First off, on behalf of everyone at RTS, we are very happy that you're with us today. I know your time is valuable, and we just really hope everyone and your families are safe during the situation with the COVID emergency that's happening globally. So a little bit about RTS Intercoms. A lot of you know that we were founded in 1975, about 45 years ago, and we're a leader in broadcast communications, but I don't know if everyone knows that we're part of the bigger company, BOSCH Global. Robert Bosch Global is our parent organization. It's the same Bosch that you've probably come to know for automotive parts, household appliances, and power tools. We have over 280 manufacturing sites across the world. We are a privately held entity, and we invest many of our profits back into engineering and development. When you take RTS intercoms and combine that with the pro audio brands such as Dynacord and Electrovoice, and you add Bosch video security cameras, we make up the division known as Building Technologies of North America. Specifically, we, RTS Intercoms, have a worldwide headquarters right here in Burnsville, Minnesota, in the States. We have 4 manufacturing plants across the globe in Zhuhai, China, Ovar, Portugal, Hermosillo, Mexico, and Lincoln, Nebraska. You can see here on the slide that our engineering staff, sales, and after-sales support have an extensive tenure in their careers. Many of the people on our staff have 15 to 20 years experience. All of the regional sales are managed throughout the country in remote U.S. offices. We have sales managers in LA, Metro New York, Chicago, Washington, D.C., and Dallas. All of our inventory comes out of 2 plants in Greer, South Carolina, and Lincoln, Nebraska. When you take a look at the slide here, you can see a lot of different broadcasters. We're very proud that we have sold a lot of product to many broadcasters across the world. Some of you on the phone here may be represented here. But we don't stop with just broadcast. RTS Intercoms is an integral part in critical communications at many industrial power plants, hospitals, houses of worship, and even space exploration facilities. And over the years, RTS Intercoms is proud to say that we've won various awards for outstanding achievement in engineering and development. So why do business with us? Some advantages across the board. Many intercom systems across North America are included in a lot of major networks and broadcast trucks. About 90% of all North American networks and broadcast trucks include RTS equipment. Thousands and thousands of key panels run across the country, run across North America. So a lot of these places have the same products completely interconnecting. We're an innovation leader in intercoms. We have a new matrix that we came out with about 2 years ago called the Odin product, a single space rack unit that can be expanded and cascaded to give you 1,024 ports. That is the industry leader in ports for intercom systems. One thing on the Odin product to let you know, our systems applications manager, Sean Anderson, will be doing a session tomorrow on Odin. So if you haven't registered for that, please do so and you'll learn more about that. As Ethan said, the SMPTE 2110 is a very hot button in the industry, and we're happy to say that we have 2 systems already implemented across the world. The CNN Hudson Yards facility has all of this working with the 2110 implementation, as well as NEP Australia. I mentioned earlier that our staff has an incredible tenure in their careers here, many of them 15 to 20 years of experience. And another feather in our hat, 0 major system failures globally in the 45 years we've been in business. So that's a very good point when dealing with RTS as your intercom system. So the COVID-19 situation has really taken us all by storm here. A couple notes that I wanted to mention about Bosch being our parent company. We have a global sourcing and manufacturing infrastructure. So because we have many facilities across the globe, we were able to handle our supply chain in a concise manner so that we never really had any hiccups with our inventory. We have a dual source strategy, so we keep inventory in multiple places across the globe. We have safety stock levels on all critical components so that if one facility is out, we're able to build product, pull parts from one place and use them to build products in another manufacturing plant. And as we saw this initiate over in China in December. In January of 2020, we put a COVID-19 task force in place, and we prepared for it sweeping across the globe so that when it did hit here in the US, we were ready for that. One of the products that RTS has specifically is the V-Link product. This is a software-based key panel that you can put on a smart device and actually use the product and connect into a matrix frame at a broadcast facility. And a lot of our users are using this product now to work from home. And one of the sessions that we'll have this week will be on Thursday, again with Sean Anderson. He'll be doing a demo of this product live to show you how this product works in today's world. So again, a review, here are the sessions that we'll have, and these will all be posted on YouTube. Yesterday we did our wireless portfolio with the BTR30 product. Today you heard Ethan do the standard session. The Odin product and Romeo wireless belt packs will be done tomorrow with Sean. And then the V-Link will conclude our showcase this year on Thursday with a real-time demo on Thursday. Everything is done at 2 p.m. Eastern Time this week, 1 p.m. Central. So with that, we're going to hand it over to Amari Ramos. He is our Global Training Knowledge Manager, and he's going to introduce a new platform that we have for the RTS products so that you can at home train yourself and get online and learn more about our products.
Thank you, Greg. Welcome, everybody. I really hope everybody is safe and healthy in this COVID-19 time. So let's talk about training. We have mainly two categories of trainings, which I would like to show you. The first category, the first type of training, are the certified trainings. So certified trainings, they are created in 3 different levels. We have professional, expert, and master levels. Professional and expert levels are the levels which are online, free of charge, available 24 hours per day, 7 days per week, that you can go and do our trainings, pass the modules, and get the certificate, official certificate from RTS. And they are all online, available in LMS, our learning management system, which we'll talk about. The second category of training we have are the self-guided trainings. For the self-guided trainings, we are talking about how to and tutorial videos we are developing, and they will be published in YouTube, our website, and also in our LMS, our learning management system. And we also have the live and recorded webinars. What we have right now is a live webinar. We are recording the session, and we will publish the session in YouTube, our site, and our LMS as well. Very good. Now, talking about our training, our 2 different levels that we have available right now. And just would like to announce from yesterday that we just launched the first level of our training. So the professional level. The professional level is an introduction for RTS Intercom training. So it's introduction for our portfolio, about our features, what we have to offer. And this is a 3-hour training. We have different modules that you can do online, and then you do an online exam and get your certificate. The next level available right now is the master level. The master level is the face-to-face training we have, the full and immersive experience with our system where you will put your hands on the system. But this will happen only after COVID-19 goes away, and then we can start over and start to offer this training in 2.5 days in our classrooms. And also this can be made by demand. We can order trainings like this way. And at the end of the training, you do an online exam, and you also get an official certificate for that. So I really, really, really recommend you to go to our LMS, which I will talk about now, how to enter it and to register yourself in our trainings. Again, the professional level, which is available right now, is free of charge and already available there. So to get our LMS, to enter there, you go to rtsintercoms.com/academy. So entering this website in our learning management system, you can create your account, and the account is totally free of charge. So you enter there, create your account, and immediately you have access to all our online materials, all our online trainings available. And then you can also do the final exam and get your certificate. So again, rtsintercoms.com/academy. Now, talking about the online materials we have, I would like to highlight some of the materials we have available. The first one is the RTS Intercom Basics. This is a basic training about intercoms. How does it work? What is a 4-wire system? What is a 2-wire system? Matrices, the key panels, and all the components for intercom system. The second training I would like to highlight is the RTS product portfolio. The RTS product portfolio is about our, all offerings that we have right now. So is a training that you can check our portfolio, all our matrices, 2-wire, and all the products we have available right now. The next one is Romeo Online Training. This is our wireless product, our wireless DECT solution. It's a really interesting material, really interactive material, so web interactive material that you can check in our LMS. The next one is the Odin Omnio Digital Intercom Training. This is really interesting material that you can experience, or we simulate the front panel of the matrix, and you can play with this matrix and check how does it work, all the menus and all the functions we have available. Okay, very good. So next one, we have an IP training as well, and this IP training comes from basics, setup, technology, and terminology. So it's a really good training about IP. And also we are covering Omnio, which is this audio transportation architecture, which also Ethan just touched, that we use Dante for the audio transportation. So we have overview, positioning, and tools. So I also invite you to go there and check this material. And the last one is Easy Edit, our configuration software, which lets you to configure to set up all our available matrices. And for trainings, again, I just would like to reinforce, please, rtsintercoms.com/academy, and you can get all of these materials. You can get access to all of them. Thank you so much for your time. So, Greg?
Well, actually, this is going to be Doug, and thank you very much, Amaury, for talking about the training. I appreciate that. And as you note, we still have time for questions if you want to put more into the chat at this time. But at this point, what I want to do is do a quick recap of what we have done today. And that is that we have looked at industry standards with Ethan, the business reasons for working with RTS, and then finally the training session that you just heard from Amaury. And on the ending slide for the presentation, it talks about the showcase that we have, the 2020 Spring Showcase, and you'll see that we have the section about pre-sales support. If you have any questions additionally, please go to presales.support@us.bosch.com. And please join us for the remainder of this week. Wednesday, as has been stated, Sean Anderson will be talking about the new Odin Matrix and is using it as a building block solution for tons of applications for the industry. And then Thursday, Sean will also be discussing V-Link, and that's the tool to enable remote production during this difficult time of the coronavirus. So with that, thank you very much for taking the time to join us, and we hope to see you again tomorrow and Thursday. Have a good day. Goodbye.